All right, welcome to the final section of rational functions lessons. It's all been leading up to this, rational equations. Boom, had to have like that New York Times font for this one. So we are gonna show a bunch of different ways to solve these. There's different strategies and different people like different strategies, and different equations lend themselves to different strategies. So let's start with a familiar one, cross multiplying, okay? So you've probably solved an equation like this before. Like this is very early algebra 1, even pre-algebra stuff. You cross multiply, right? You multiply these and you multiply these and suddenly you get this, right? 3 times x is 3x. X plus 5 times 2, you have to distribute 2x plus 10. Well, look at that. I even set it up for you so you saw the in-between step. 2 times x plus 5, distribute 2x plus 10. And honestly, I skipped all the steps in between because by this point, yeah, subtract your 2x, you got x equals 10. Now, because you do have stuff in the denominator, you're gonna need to check to make sure you don't have extraneous solutions, okay? So there are excluded values, so you have to make sure that you don't accidentally hit on one of those excluded values. X being 10, if you plug it back in, doesn't look like it's one of those, right? 2 over 10, 3 over 15, I think we're good. If you plug in 10, that's what this 3 over 15 is. It's 3 over 10 plus 5. Is that equal to 2 over 10? Okay. 3/15 equal to 2/10. Are you thinking about it? It's 1/5 on both sides, right? It's 1/5. Either way, it's right, so check. This works, okay? Cross multiplying. Nice, easy way to start things off. All right. So, you know, this is gonna get crazy. It is. It's the final chapter. It's gotta get crazy. All right. Now we're going to use the least common denominator, all right, to multiply out. All right. We're going to do the simple one, and we're going to get it to this stage right here, and then I'm not going to solve it any farther. Well, we'll see if my willpower holds out. I do love to solve that stuff. All right. So we have right here the original. It's kind of squished in. All right, sorry about that. Kind of squished in. This could be better formatted. This is the original. 4 over y plus y over 2 equals 3. Okay, look at that. We don't have a common denominator. We have a 1/5 times 1/3 kind of situation here. We're going to have to multiply this whole thing times 2 over 2, and this whole thing times y over y. All right. The other thing you could do is you could just distribute a 2y and cancel, okay? So let's look. I didn't get rid of that, okay. You also could say, I know this is gonna be 2y, so you're gonna multiply both sides of the equation by 2y. Okay, so here we've got 2y. Notice the different colors of canceling here. All right, when I multiply 2y times 4 over y, because remember this is 2y over 1, and we're distributing, right? We're distributing, so I'm just doing the first term now. We have 2y over 1 times 4 over y. I'll write it out over here. This is less messy looking. 2y over 1 times 4 over y. And you can see we can cross cancel this y. That's what that yellow mark is, okay? That leaves us with just 2 times 4, which is 8. Now we're going to do 2y times y over 2. 2y over 1 times y over 2. Well, what cancels here? The 2 cancels out. Okay, so now we've got y times y, which is just y squared. And over here, 3 times 2y is 6y. So I've got rid of my denominator entirely. Like there's no more denominator. I've multiplied it away. It's all gone. Our common denominator would have been 2y. We could certainly make a common denominator and do that. But you can also just get rid of it by multiplying this whole thing by what the common denominator would have been. Okay. Now we've got this situation where we've got 8y, or 8 plus y squared equals 6y. Do a little rearranging, subtract your 6y, you know, and ta-da, you've got a perfectly adequate quadratic equation that you all know how to solve with X games, right? I know I said I wouldn't. Multiplies to 8, adds to negative 6. What's it gonna be? Think for a second. Oh, it's gotta be 2 and 4. And the 4 is gonna be negative. Wait, no, what am I talking about? They're both gonna be negative. Yeah, because negative 2 times negative 4 is positive 8. All right, and they add to negative 6. So that means that your roots are going to be, or your factors are going to be y minus 2 times y minus 4 equals 0, which means your roots are going to be y is equal to 2 and 4. Oops, there you go. I did it anyway. I swore I wouldn't, and I did. All right, so again, the real main part of this is that we got rid of the fractions entirely by multiplying them by what the lowest common denominator would be. All right, so we're going to take this example, and I am going to put it in the next sort of slide so that you can see it still. This will look familiar at the top here. That's what we just did, right? We got it to there. And we're going to, like I said, take this to another level of complexity. So again, do not panic. I got my little pink highlighter out. We will go over it a piece at a time. All right, don't be overwhelmed like this is crazy. I have this here so that you can see the simplified idea and compare it to the more complex idea, so we can go back and see, oh, we're just doing the same thing. It's just a lot more hairy looking, okay? So we have 4 over y plus 5y over y plus 1. This is our original equation. It equals 5. Okay. Now, we've got to get rid of this denominator, so we have to find the lowest common denominator. That's going to be, well, y times y plus 1, right? If we were to find a common denominator, it would be y times y plus 1. This one needs a y, and this one needs a y plus 1. So we're just going to multiply both of these expressions, both this one and this one, times y times y plus 1. We're going to multiply by what we thought the common denominator was going to be, because it's going to cancel out the stuff in our denominators. Okay? So now we're here. I have taken our y times y plus 1. I've put it over 1 so that I can just sort of show you guys that, yes, we can cancel stuff, right? Sometimes it helps students to see, oh, yeah, that's in the numerator, that's in the denominator. Okay? And then, of course, I have my 5, which has to be multiplied by, and that's where the extra parentheses come in, sorry. Y times y plus 1, all of that multiplied to 5, right? So let's just do this section. We're just going to multiply out this section right here. And that's what I'm showing you right down here. Okay? These two things are the same thing. I've just sort of broken them out for the distribution part. Then I have this one times this one. Okay? Let me put that in another color. Now the second one underneath there is the orange times this one. Okay? That's what this piece is right here. So y times y plus 1, that's our denominator, times 4 over y. Okay, cool. Let's cancel that y and cancel that y. Now I have y plus 1 times 4. Cool, y plus 1 times 4. There it is. Over here on this one, we've got y times y, oh, the y plus 1s cancel on this one. And we're left with y times 5y, which is 5y squared. There it is. And we're adding them together, right? And then finally, we've got this. So this would be, right here, y squared plus y, and all of that, times 5, which gives us 5y squared plus 5y. All right, I know, lots of little moving pieces. Okay, and this I know looks crazy right now. Just have to be deliberate about it and think, what am I doing? Well, I'm finding a common denominator and I'm multiplying it times both of the terms. I have to distribute it. That's going to cause their denominators to cancel, but we still have to deal with their numerators. We have to multiply it on this side too, and there it is, okay? So, I'm going to clear this. All right. This expression here, we can simplify it to 4y plus 4. And this expression here, look what happens. We've got a plus 5y on both sides of the equation. That means when we subtract 5y, it goes away, and it's just gone, and it is equal to 5y, and suddenly, super easy, right? Subtract your 4y, and voila, y is equal to 4. Okay. In a weird way, this doesn't, once you get to the quadratic at the end, this takes, about the same amount of time. It just looks a little crazier, maybe. I don't know. Your opinion might be different, but I think that this one is not as bad as it looks. It just has lots of parentheses. So when you look at it all at once, it's a little bit scary. But if you break it down, once again, all we did, we said, this is our denominator. I'm going to multiply this times the denominator, and I'm going to multiply this times the denominator, and I'm going to multiply this times the denominator. And we did. Okay. And then we simplified, and we're done. All right. A little more tricky there, I know. Okay. Let's do it. Oof, 1 plus this equals this. Okay. Well, c squared plus 2c, that does factor, so, maybe, oh my gosh, there's so many things we can do. We could turn all of this into one expression. We can use our mixed expressions, turn it into one expression, and then we can cross multiply. That's one thing we could do. The other thing we could do is, anytime I see something like this, I think, well, what if I factor that? Is that going to give me anything? Can't hurt, right? Let's just try it. C squared plus 2c, that turns this expression into 1 plus 1 over c plus 2 equals 28 over, if we factor out a c, then we've got c times c plus 2. Oh, now my c's look like my parentheses. Okay, we got two c plus 2's going on. So, what can I do? Maybe if I turn this into a mixed expression then, like turn this mixed expression into one thing, then we can multiply stuff out. Well, that would be the same thing as, remember, 1 is the same thing as c plus 2 over c plus 2. Okay, I'm going to actually change my color here so you guys can see that I'm kind of doing something a little bit separate here. C plus 2 over c plus 2. Okay, it's the same thing as 1. And then we're going to add that to 1 over c plus 2. What does that equal to? Well, our denominators are the same, so it stays c plus 2. And then c plus 2 plus 1 is c plus 3 over c plus 2. Cool. Okay, so now my whole expression, like this, is this whole side of the equation. That's why it's useful sometimes to be able to turn a mixed expression into a regular rational expression. Okay, so now I've got this piece here that's useful, and I've got this piece here that's useful. Let's put it all together. All right, so now I have, on this side of the equation, I have c plus 3 over c plus 2, and it's equal to 28 over c times c plus 2. Okay, what can we do from here? Well, we could cross multiply, but in this case, let's look at this. This would be a really big, hairy mess to cross multiply, wouldn't it? Yeah, I'm not sure that's the best idea. We're gonna get some like cubics in there and stuff, and like what? Like, I don't know. Maybe that's just too much of a hot mess. Maybe we can, let's see. I guess we could do it, but maybe it's not the best strategy. What if instead we make this have the same denominator? If I multiplied both sides of this by c times c plus 2 over 1 on both sides, oh my gosh, I'm sorry, my c's, I really need to make them look more like c's. C plus 2 over 1 on both sides. That's the common denominator, right? Now we had this situation earlier, but it was for stuff on one side of the denominator. Now they're on opposite sides, but you still have to multiply both sides by it. This should cancel some stuff out. Okay, well, let's see what we cancel. On this side, we obviously cancel this whole thing out. This side just turns into 28. And on this side, we cancel out our c plus 2's, and we're left with c times c plus 3. This is very doable. We can do this. We turn this into a quadratic really quickly. C squared plus 3c equals 28. And lo and behold, just subtract that 28 over here, c squared plus 3c minus 28 equals 0. You can now try and factor it. If it's not factorable, then maybe you can complete the square or use the quadratic formula. Either way, you've got it to a stage at which you can work with it, right? It's much easier to work with this than it is to work with this, right? And we used a couple different techniques here, right? We took a mixed expression and turned it into a plain old rational expression. We used factoring in the denominator, and that showed us that we could multiply away our denominators by finding a common denominator and multiplying both sides by that common denominator. Okay, got rid of that entirely. There are, of course, other ways to do this. This is just the techniques I'm showing you here. All right, so now we want to multiply to negative 28 and add to 3. So I'm thinking we're going to have a 4 and 7 type of action here, and the 4 is going to be negative. All right, so we have c minus 4 times c plus 7 equals 0. And therefore, c is equal to 4 and 7, maybe. Remember, this is a rational expression. We need to check our answers. Okay, so let's plug them back in and find out. Whew, all the way back to the beginning here. I'm going to use an answer check color. Let's use green. All right. So we're going to plug in 4. So 1 plus 1 over 4 plus 2 equals 28 over 4 squared is 16 plus 2 times 4 is 8. Okay, so this would be 1 and 1/6. Is it equal to, let's see, 28, 16 plus 8. That's going to be 28 over 24, which simplifies to that side right there, not the whole thing is equal to, but that side right there is equal to 1 and 2/24. 4/24. There we go. 4/24. It's like, no, that was not right. 4/24, which simplifies into 1/6, which equals 1 and 1/6. Good. Okay, so 4 is a good solution. Now we're going to go ahead and try 7. Okay, let's try 7. We have 1 plus 1 over 7 plus 2 is equal to 28 over 49 plus 14. All right. 1 1/9 is equal to, that doesn't look right, does it? Because it's already wrong. Look, 28 is smaller than 49 plus 14, so it doesn't even matter what 49 plus 14 is. It's going to be, nuh-uh, right? So 7 is an extraneous solution. All right, here you have it. Your answer is 4. C equals 4. Whew. All right, we're not going to do that one actually, even though it has a cool picture of a mammoth on the beach. We're not going to do that one. I just wanted to review ways that we solve these, okay? Cross multiplying. If you have a fraction equals a fraction, you can always cross multiply. Now notice I didn't choose to do that in the last one. That doesn't mean you can't, right? The last one I didn't choose to because it would have ended up with a cubic and it would have been a little bit messier. This would end up with a quadratic and you'd be fine, right? You could totally turn this through cross multiplication into a really simple quadratic. Fraction equals fraction, great way to go, okay? Another option, you combine 2 like denominators and then cross multiply. What? Look at this. Well, we've got a like denominator here and a like denominator here. Maybe if we can just get this one to match this one, then our lives are easy, right? I have denominator 1 plus denominator 2 equals denominator 2. Or plus or minus, I guess. I don't think I meant plus, I think I meant times. Oh, I see what I'm doing, yes, okay. I definitely confused myself with this one. What I meant was in the situation where you have a denominator and then you have a different one, but then this one has the same one as this one, or they're flipped around and these two have the same denominator, but this one's got a different one, you can combine the like denominators and cross multiply. That's all I'm trying to say, is you can combine your like terms denominators. Like you could get, okay, this is really confusing, so I'm gonna make sure I clarify here. Let's say we had like, I'm gonna do this with regular fractions. Like 5 over 3x plus 2 over x equals 15 over x. See what I'm saying? This is denominator type 1, denominator type 2, denominator type 2. You could subtract this from that side and combine these first and then cross multiply. Same thing here. You could combine these first and then cross multiply. That's all I'm trying to say with this very strange and misleading I need to fix it slide. All right. Or find a common denominator for just one of the terms. All right. You want to do this when one of the denominators has the other one as a factor, right? X squared minus 16 has x plus 4 times x minus 4, right? It has an x plus 4 as part of the factor, so you only have to mess with this one. You only have to do the x minus 4 over x minus 4 over here to solve it, to get it to have the same denominator, and then you can pretty much ignore the denominator and go ahead and solve, okay? Find a common denominator for everything. That's kind of what we were doing in the previous slide. Find a common denominator for all of this stuff. And you do this in a situation where you have, 1, 2, and 3, or, one type of denominator, three totally different types of denominators, or 2 types of denominators and a constant. When I say a constant, I mean like just a whole number, or like 15 or 25.2, just like a number, no variables, okay? That's where you would use finding a common denominator for all of them. So if I'm looking at this, I'm gonna go, oh great, I'm gonna probably find a common denominator for 13, 7x, and x plus 2. I'm gonna multiply all that together, and then I'm gonna cross cancel it out to get rid of my denominators in general, because it's really the only thing to do. This is not a pretty expression to solve, an equation to solve, but again, you just get through it, You cancel this one out and then multiply that to whatever's left over. Cancel the denominator, multiply the numerator to whatever's left over. Okay, just chug through it and get through it. All right, that's pretty much all I have to sum up on this topic. If you're interested to see me work some of these all the way through, then, that's my phone. Then you know, I can probably do that in a subsequent video if you make a request for it. All right. Thank you so much for this series, and I will put more stuff up as people are requesting different topics. Bye, guys.